Okay, eighth grade, here are some more notes for you to help you out in section EE. Experimental probability. Experimental probability is when you actually do a simulation here. You're gonna, for example, you roll a number cube or a die marked 1 through 6 10 times, and you get a 4 6 of those times. Your experimental probability is 6 out of 10. You got that 4 6 times or 3/5. So based on your experiment or your trial, how many times would you expect to roll a 4 on your next 20 rolls? So you take your probability of 3/5 and multiply it by 20. And 20 times 3/5 is going to be 12. 20 times 3 is 60, and 60 divided by 5 is going to get you 12 times. So you'd expect 12 times that you would roll a 4 based on your experiment. Another example here, when you're making predictions, pies sold, you sold 1 raspberry pie, 4 blueberry pies, 2 chocolate pies, 2 lemon pies, and 1 banana pie. So considering this data, how many of the next 20 pies sold would you expect to be blueberry? There were 4 blueberries sold out of the 10. 1, 5, 7, 9, 10. So the probability of that would be 4/10. How many would you expect out of your next 20 pies that would be blueberry? You just do 20 times 4/10. 4 times 20 is 80, divided by 10 would give you 8. You'd expect to sell 8 blueberry pies then out of the next 20 that you did sell. Okay. Compound events. When you're trying to find compound events, you find the probability of both of them and multiply them together. So what is the probability of rolling a die and getting a 4 and flipping a coin and getting heads? Well, the probability of getting a 4 is going to be 1/6. There's 1 4 out of the 6 possible numbers that you could land on. What is the probability of landing on heads? That would be 1/2. You multiply those together and you end up with 1/12. The probability of rolling a 4 and getting heads then is going to be 1/12. And then the probability of getting an even number in tails, there are 3 out of 6 that are even, which is 1/2, times the probability of getting tails, which is 1/2, multiply those together and you get 1/4. Some definition for you: dependent event, if the outcome of the first event can affect the second event, that would be dependent. An example of that would be if I drew somebody's name out of our class to see who would go first, that will affect the rest of the outcome because I'm not putting that person's name back into the set of data. An independent event, if the outcome in the first event does not affect the second event. So if I'm drawing cards and then I replace that card back into it, it's not going to have an effect on the second one. So if I had the numbers 4, 5, 6, and 7, what is the probability of drawing a 4, then a 5? Now I'm replacing that 4 back into the set, so the probability of getting a 4 is going to be 1/4. The probability of getting a 5 is going to be 1/4. The probability then of getting a 4 then a 5 is 1/16. Now if I have those same numbers, 4, 5, 6, and 7, and now I'm not replacing after my first draw. What is the probability of getting a 4, then a 5? Well, the probability of getting a 4 is going to be 1/4 times the probability of getting a 5. And if I'm not replacing, the 4 is no longer in my set. That's going to be 1/3. And the probability of that happening then would be 1/12 because I'm not putting it back in to my set of data. Okay. And that would be a dependent event that affected what happened on my second draw. So those are just some things that should help you. Again, take your time on section EE. There's a lot of different things to do, a lot of new stuff. If there are any questions that you have, just go ahead and email me. And good luck, and everybody have a great weekend.